All right, here goes video number one. Excuse me. I'm gonna have to do some adjusting to this as we go. I'm trying to make it so that the focus stays good. Just so you know, here's the cumulative formative, and I've got it beside me, so I am looking at it, and I am going through, and I'm gonna kind of tell you what problems on the formative are similar to the problems that we're going to be looking at on here. So number one, I'm doing the quick check first. And number one on here, I cannot find, I have a whole bag of erasable pens somewhere, and I can't find them things nowhere. I had them the other day. I don't know what I did with them. All right, so on this, we have got to read these and look at this scenario down here. Now, every time that we have done anything that had a minus sign in the middle, we've changed it to addition, okay? But let's just kind of read these scenarios. Now, the problem that's on the formative that is similar to this, you're matching the actual expression that would be the same thing. So I'm going to show you this, what I call the equivalent expression. I'm sorry, guys, I got the hiccups. The equivalent expression after we do this question, okay? I'm going to show you what this question looks like on the formative, all right? It's a little bit different, but it's the same type of thinking, all right? But let's look at this. So right here, I'm just going to start at the answer choices. I want to see what the answer choices say. I want to see what they look like. Mania, I have no idea. Mania has $22 and she spends $5.80 on snacks at the movies. So let's just break this up and look at what that is. She has $22. That means that's going to be a positive $22.50. She spends $5.80. That's going to be minus $5.80. All right. To help you out a little bit, let's go up here, and the ones that are subtraction, let's change them to addition. Let's change these subtractions to addition. Now, I want to just show you something. This is not absolute value. I don't want you to think that. So think along the lines of, this is one term. That is a positive $22.50. This is another term. That is a positive $5.80 right now, okay? When we have a minus sign sitting right here, no matter where we have a minus sign, it don't matter. It's going to mean the opposite of. It's going to mean you got to take the opposite of whatever's to the right of it, okay? So here's our $22.50, and we're going to have to take the opposite of $5.80. When we put these together, we've got to do the opposite of $5.80, which is negative $5.80. Okay? Anytime you got a minus sitting out there, you're going to do the opposite of. Now, this is the same thing as what we talked about, our KCO. We kept the first term, we changed this to addition, and we took the opposite of the second term. The minus sign has meant the opposite of since we started doing all of this. That minus sign means we got to take the opposite of. We've got two terms, and the second one, we're going to need the opposite in order to be able to do what we need to do. So now if you look right this, she had $22.50, and she spends $5.80, and she spends $5.80. Look at there. Those two match. So this one is A. All right. Mania spends $22.50. All right. She's going to spend $22.50. If she's spending $22.50, that means that's a negative $22.50. Just going to write it right in there on top. I'm using a pen so that it stands out on this dark background right here. Y'all know we don't do math with a pen. She spends $22.50 on concert tickets and another $5.80 on popcorn. So she also spends $5.80 on popcorn. All right. And she spends $5.80 on popcorn. All right, let's go ahead and do this one. Mania has $22.50. That's going to be positive, $22.50. And then she earns $5.80. So she's getting $5.80. And then on this one, she's spending $22.50 on a new jacket. And then she earns $5.80. Oops, spends $22.50. That's a negative $22.50. And then she earns $5.80 for walking the neighbor's dog. Okay? So now, looking at these, how do they match up here? Well, before we do that, let's look at this one. Let's go ahead and make this one addition. So we've got this negative $22.50, and we've got this positive $5.80. And we've got to do the opposite. We got to KCO it. So this becomes negative $22.50. We keep the first term. And a negative $5.80. If we change that to addition, now it makes sense. Look right here. Negative $22.50 plus a negative $5.80. So this one is B. She's got, all right, this is $22.50 plus $5.80. So this one would be C. And this one's negative $22.50 plus $5.80, which is D. And what's happening right there is exactly what you're going to be doing on here. Because on the summative, or on the formative, it's going to look like this. I'm just going to get another copy. I'm going to get another copy and put it down here. Actually, I'm going to put these side by side because I want y'all to see what I'm doing. On the formative, the top looks exactly the same, but the answer choices are different. And the top doesn't have the answers out here. So on the formative, you don't have this. You just have these. And then you have answer choices down here. So then down here, answer choice A would be 22.50 plus a negative 580. Answer choice B would just be the negative 2250 plus a negative 580. This would be 2250 plus 580. And this one would be a negative 2250 plus 580. So you don't have all of this on the formative. So you don't have all of this. So you've got these problems, and then you got problems like these, and then the equivalent expression that you've got to match it to. Okay, so you got these problems like this, and then you got to match it to the equivalent expression. And all of the all of these up here are subtraction on the formative. Okay, so when you're doing that, what are you going to do? Well, you're going to take this, you're going to KCO these first. So we're going to box that off so that we can keep the first term. So if we keep the first term right here, we're going to have 2250. We've got to take the opposite of the second term, which is a negative 580. And then it always gets the plus sign in the middle. We keep the first term, change this to addition, and take the opposite of the second term. And then you would match that to the answer choice down here that it matches with, which would be that one. if it were this, these same problems. That one's already addition. Look at this one. So we're going, the ones on the formative are all subtraction. So you're going to have to KCO all of them. You got your first term, you're going to keep it. So come right over here and keep the first term. Negative 2250. Change this to a plus. Take the opposite of the second term. The second term is positive 580, and we need a negative 580. Because we're going to box that off, leave this on the outside. We're taking the opposite of that 580. So that would be a negative 580. So your answer choice would then be that one. If it were B, then your answer would be B. So on the formative, you don't have these verbal expressions on, it's number 17 on the formative. You don't have these verbals. You have problems like this that are all subtraction. You've got to KCO them and then match them to their equivalent expression down here after they've been KCO'd. After you have rewritten it as addition using the opposite. Okay? So that's kind of how that links back to what we're doing on that formative. Okay? On number 2, there are some number lines on here that are addition, and there are, but they're not a lot of, so let's just look at these, and then we'll talk about how it kind of will help you with what's on the formative. So you're matching these number lines to this. The first thing you need to do on these number lines, come up here to these number lines. Because I don't know if you remember me telling you that we don't write addition or subtraction, the combining. We don't write our combining number lines the same way we write our multiplication number lines. This right here means that we've got some combining going on because the number lines are stacked. This means that we've got multiplication going on because the number lines are butted right up against each other. No, I lied. I hate this. I do not like this number line. I would much rather this number line have a line right there. And this number line needs to have a line right there. I don't like that. I don't like that. That, to me, is misleading. But you may see it that way. So I guess we need to look at them that way. But to me, the butted up equally, and here's where I know, this is how I know this is not meant to be a number line for, how I know that this is not meant to be multiplication and this is not meant to be multiplication, because the two groups are not the same. These two groups are not the same, so it can't be multiplication. They just didn't stack those two number lines, and I don't like that at all, but I don't have any control over it, and I guess maybe you may see them that way some, so they've thrown some in there. So let's label these first, though. Let's just look at what's happening. We start at 0, and we go back to -6, so that's a -6. Then we start at -6, and we're going 1, 2. We're going back to the right 2, so that's a +2. So something down here has got to be worded so that we're losing money, or we're losing something, we're spending something, we're doing something to make us lose 6 and then gain 2. Right here, we are losing 6 and then losing 2 more. Right here, we are gaining 6 and then gaining 2 more. Right here, we are gaining 6 and then losing 2. So let's read these and see which one. Carlin spends 6 tokens. Spend 6 tokens means that we are losing 6 tokens. So we're going to do any of these number lines where we start at 0 and have a -6 are going to be this one. So if we're looking at these, it could be either one of these. We start at 0 and go back 6. We start at 0 and go back 6. So it could be either one of these, but not these, because we start at 0 and go forward 6. Then he wins 2 tokens. So he goes back 6, and then he wins 2 tokens, and then plus 2. So we're going back 6, and then forward 2. So this is going to be the answer for that one. All right. He wins 6. Now he's winning 6. Carlin wins 6. That's going to be a plus 6. And then he spends 2. That's going to be a minus 2. So we're looking for a plus 6 and a minus 2. Well, here we go. Plus 6, minus 2. So that's going to be B. Now, I ain't telling y'all this in class today, but I'm very seriously thinking I might let you use these things on the quiz tomorrow. On the formative tomorrow. Or at least give you a few minutes with them on it. Maybe not the whole time. If you will write out everything that I'm doing on here, make yours look like mine. I don't care if it's sloppy, because I am going to be taking them up anyway. But if you will write out everything that's on here the way I've got it, it's going to help trigger you into making sure you can think about these problems that are on this formative the way you need to. You do need to make sure you're answering these. I am going to take these up and do some kind of little grade on them. I've got to have one more daily grade. Okay? You should make 100 because I'm doing them all. Carlin wins 6 tokens. He wins 6. So we're going to do I'm going to change colors so that you can see better. These pinks are running together. So right here, we're winning 6. We're winning 6 right here. So that's a plus 6. And then he wins 2 more. So now that's another plus 2. So we're looking up here to find that plus 6 plus 2. There it is. So that is C right there. Carlin spends 6 tokens. He spends 6. So that's a minus 6. And then he spends 2 more. That's going to be a minus 2. So we're minus 6 minus 2. All right. So, like I said, make yours look like mine, and you will be golden. Okay. Identify the model that best represents each expression or phrase by marking it with a check mark or an X. This one aligns directly to number 16 on the formative. Number 16 on the formative is a number line instead of this, but it is the same, it's the same thing. So we need 2 sets of -3. Well, that's 2 sets of positive. So this one right here aligns to that. The opposite of 2 sets of -3. Well, the way I want you to approach this is we're going to do the opposite of 2 sets of -3 is ... what? The opposite of 2 sets of -3 is 2 sets of +3. So this is what we're looking for. 2 sets of +3. Put that is in there, and that should help you. When you have the opposite of, you want to have a is. The opposite of 2 sets of 3 is 2 sets of -3. And that's what we're looking for right there. Now, on these, we're going to write the verbal expression out here. And then we will, so this one means the opposite of 2 sets of negative 3. So this is the opposite of 2 sets of negative 3 is 2 sets of positive 3. And that 2 sets of positive 3 is what we're looking for. Okay? This one, that's the opposite of 2 sets of positive 3 is 2 sets of negative 3. So on this one, the opposite of 2 sets of positive 3 is 2 sets of negative 3. We're looking for 2 sets of negative 3. So on this one, it would be the 2 sets of negative 3. I'm going to change colors one more time so that we can try to keep this hot mess a little bit. This one, that's going to be 2 sets of negative 3. 2 sets of negative 3. 2 sets of negative 3 is that right there. And this is 2 sets of positive 3, which would be this. Okay. And again, on the formative, you're actually doing these same type of problems, but they're on a number line. And I think that looking at the number line, so let's take these for a second and just look at what they would look like on a number line, okay? I have to back it out a little bit. Ooh, I hope I don't mess this up. Come on. Ooh, that's too far. That's still too far. Okay, now, let's see if we can make that work. I'm gonna get a fresh, clean copy. I'm just splitting between 2 copies because I'm writing on, when I'm changing it up and doing the same thing, I'm doing the same problem, but more like what's on the assessment. I am just switching between the 2. So, let's take this. So on the quiz, you're going to have 2 sets of negative 3, and you're going to have a set of number lines, and you got to choose which number line matches. Well, let's look at what 2 sets of negative 3 looks like on the number line. 2 sets of negative 3. That means we're going to start at 0, and we want 2 sets of negative 3. So there's one set of negative 3. There's another set of negative 3. So now we have 2 sets of negative 3. And on the assessment tomorrow, on your cumulative formative, if you will draw those lines like that on your number line, where they, where each section is, it will help you better see the sets and how many are in each set. Now, one thing I do want to make and call your attention to is making sure you pay attention to the intervals that's on the number line, because they may not be numbered by 1s. They may be numbered by 5s or 10s or 2s. Like if you look at this number line right here, this one's numbered by 5s. So that one wouldn't be an easy one to be able to do 2 sets of negative 3 on. But pay very close attention to the number lines, to the number line intervals. All right? Let's do a couple more of these right quick. The opposite of 2 sets of negative 3. Well, here's 2 sets of negative 3 right here. This is negative 3 and negative 3. So that's 2 sets of negative 3. Well, the opposite of 2 sets of negative 3 is 2 sets of positive 3. So the opposite of that would look like this. One set of positive 3. Here's another set of positive 3. Plus 3, plus 3. 2 sets of the opposite of 2 sets of negative 3 is 2 sets of positive 3. But, so, the questions on your formative, the questions on the formative, it's a table that looks like this, but then you are matching them to number lines that look very similar to this. They have the little humps on it, and you're having, so instead of it being a color counter model up here, these are number lines. On the assessment, these are number lines. And so you're Xing off which ones show, okay? Let me go back to this one. What is the vertical distance between a rabbit hole that is 1 1/4 feet under the surface of the ground and a bird's nest in a tree that is 12.5 feet above the ground? Well, I'm not gonna lie to you. When I have a problem like that, vertical distance, I tell y'all right off, I'm gonna draw a picture. I'm gonna draw a picture. It helps me so much better. So here's my ground. Ground level is at 0. So I've got a hole 1 1/4 feet under the ground. So that's going to be a negative 1 1/4 feet. And I've got a bird's nest that is 12.5 feet above the ground. And I want to know the vertical distance between them. Basically, I want to know how far apart is that bird's nest from that hole in the ground, from the bottom of the hole. So you're just wanting this, okay? You're just wanting this. And anytime you are trying to find distance, you are going to take the difference. Distance means difference. Distance means difference. Now, here's the other catch to doing that. You want to draw your picture because you're going to want to do the 12.5 in the front. That's going to be your first term. 12.5 minus a negative 1 1/4. This is how you would find that distance between the two of them. This is how you would find that distance between the two of them. All right. I'm going to show you again how to put this in the calculator. To put this 12.5 in, I'm going to do second and then my fraction button, and it gives me my mixed number minus second, fraction button again, minus a negative. We're minusing a negative 1 1/4. Okay? So we get 55/4. Well, that don't help us none because we need that to be into a mixed number. So to get this into a mixed number, you're going to do second, this X10 N key. I don't know what it's called officially. I just call it the X10 N key. And then hit enter, and you get 13 3/4. So 13 3/4 feet is the distance between here and here. Okay? Now, distance is also absolute value. We're going to do one. Distance is also absolute value. Distance is difference. Distance is also absolute value. Distance is also absolute value. So, we can work in all positives. And you can see, we can work in all positives. So, think this way. How far is it from here to here? This distance right here is 12.5. Plus, this distance right here is 1 1/4. We're working in all positives because we're thinking absolute value. Distance from 0. This is the distance from 0 is 1 1/4 feet. The distance from 0 is 12.5 feet. If you look at it from that perspective and just talk about, okay, what is the hole's distance from 0? What is the bird's nest distance from 0? If you're thinking about it in terms of just the distance, you're thinking in terms of absolute value. You're going to just work all in positives because we're going to be using all absolute values, and then we're still going to get 13 3/4. And I'm not going to lie to you. I'm just going to tell you straight up. If I'm not asked to write that right there, I'm probably going to draw a picture and use absolute value to find the distance, the total distance. If I'm asked to find the total distance and I'm not asked to write the math problem that goes with it, I'm probably going to draw a picture, because that is one problem-solving strategy. That is a problem-solving strategy I use a lot, and it's okay that you use it that way. But some of you may want to write the math problem and do the math problem. I'm a visual learner, and I know that drawing a picture is one way that I can get myself there and feel good about it, okay? Yesterday, the low in Boston was -3, and today the low was predicted to be 8. How many degrees warmer was today's low than yesterday's low? All right, guys, we ain't going to overthink this. We're going to use the number line again. We're going to use it vertically this time. All right. I guess I could cut this off, couldn't I? All right, so I'm going to cut us the number line off, and we're going to look at it on here, and then we will look at... To me, it's just easier to do... If it doesn't ask me for the math problem, if it don't say write the math problem, write the expression, write the equation, write the whatever, I'm not going to. I just won't. I know I won't. That's where my brain goes. My brain goes to a picture. But your brain may not. So I try to make sure I show you all of the different ways. All the things, okay? So yesterday, the low in Boston was -3. So here's the low. The low in Boston was -3. And I will have some number lines on the table for y'all to use tomorrow. Today, the low was predicted to be 8, which is right here. How many degrees warmer? Okay, we ain't going to overthink this. We're going to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It was 11 degrees warmer. Hello. There you go. There it is. Now, it was 11 degrees warmer because it's wanting the distance from -3 to +8. From -3 to 0, or 3 is 3 places. From 0 to 8 is 8. So 8 and 3 is 8 plus 3 is 11. That's working in absolute values when you're just looking at distance. If you're just looking at distance, you're working with absolute values. Therefore, you are working with all positives, and you don't have to. Distance from here, and then the distance from here. This distance was 3. This distance is 8, and together those make 11. When you're thinking in those terms, you are working with, you're thinking in absolute value. You're thinking in absolute value. Now, if we are going to do it using an expression or an equation, you've got to take your highest value first. Your highest value has to go in the front, because we're going to take 8 degrees and find the difference, because distance is difference. Distance is difference. Distance is difference. So we're going to take that 8 and we're going to find the difference in 8 and -3. When you do that, You put that in the calculator, you're going to get a positive 11. If we use the rule to do that, or if we go back and think about if we KCO'd that, it would be 8 plus 3, which is 11. Because we're going to keep this term, we're going to change that to a plus, then we take the opposite of that. And so now we're still going to get 11. But any one of these is okay. If you just write 8 minus a negative 3 and put it in the calculator, that's good. If you use the number line and get 11, then that's good too. Okay. Amber lost 8 bobby pins. I'm going to try to explain this to you. I'm going to try to do this with the counter model. Amber lost 8 bobby pins. She lost the same number each week for 2 weeks. Draw a counter model to represent how many bobby pins were lost each week. Okay. So we've got to do a counter model to see how many bobby pins we lost each week. Well, let's write the math problem out first. Okay. We're going to write out our math problem. She lost 8 bobby pins. And she lost the same number each week for 2 weeks. So we're going to have 8 divided by 2. We're taking a total of 8 bobby pins. And she loses the same number every day for 2 weeks, or the same amount every week for 2 weeks. How many bobby pins did she lose each week? Well, what this is asking me to do is to take negative 8 and I really think I'm going to stop right there a minute.